is insert library, read out the init file when creating, like this is the file task to create the test executable. And so we read in that init file that we generated, and from there we basically ends up looking like this, where we take the assert, the internal representation of the bytecode for the assert library, and then load it here. And it basically turns into like 630 lines of bytecode. Like I just folded this up. And then from there, it loads the actual tests, which turn into about 13,000 lines of bytecode on mruby itself, like including all of the libraries. And then if you have gems enabled and you're linking to gems, it'll run all of their tests. And basically, when it's generating this function for each gem, it creates a new function here to init, and then generates a function call for each gem that you link to. And it basically, for the default standard library, looks like this. So it's just one function called, very straightforward, and then it builds, right? If we look at actually the output of the compiler, it helps us quite a bit understand. Here we can see where it's compiling. These are MRBCs, is bytecode calls for all the test files that mruby links to. And then starts here, it goes through MRB test, compiled executable, and then we can see where it moves on to assert, compiles it to bytecode, compiles that C file, and then links it, and then it continues to go through each of these standard library gems that we link to, or any gems really. It doesn't have to be standard library. This is sprintf, this is the first one it goes to. I'm not sure on the order or anything, but that's what basically it goes on to. Compiles that to gem test, and then these gem test files are linked. And then it executes. And it takes about 0.18 seconds. This is literally just an executable, a binary per se, that we could take and run it again whenever, basically. And it just has all of our code linked statically, all of the tests included, right? So it packages all that into a test. And this is something that mruby can do, and I think it's brilliant, and I think it's really great that we have this ability in Ruby. We haven't had before. And how many of you are still with me? All right, good. For a better understanding, I think it'll help if we build something-ish. And so I want to introduce my little library that I built. It's called mruby static, and it's inspired by Jekyll, and I just wanted a way to write Markdown and preview it in a page. And so I used mruby to do this. I thought it was pertinent when someone tweeted this. They said Jekyll has too many dependencies, one of them being Nokogiri. It takes forever to compile. If any of you have ever compiled a huge Jekyll site like rubylang.org, it takes like 13 to 15 minutes. It's like, why does it's just JavaScript and HTML? I don't understand. So I gave up and built this. And I have some to-dos. If you're interested, come talk to me. Like, we can hack on it. I'm going to show you, walk through the code right now. But if I demo it, I can show you basically, like, I have a site, it just has a site.rb file, source has the static CSS file, and I have the binary static that I generated. I'll show you exactly how I created the binary, but basically we can create a new post and pass in a string as the title, and it just creates a file for us. And if I open that up, we see my contents here. So it's just a starting point for anything like you do with Jekyll, basically, right? But there's no metadata, because why do I need metadata? I don't know. So if we want to preview this page, we can run preview run, and then just copy this URL, copy that URL, and then open our browser, paste, and we get a 404. Oh, because I didn't type the name in. I don't remember what I recorded. All right, your content here, okay. All right, and then I proceeded to take the README from the file, because it's just a markdown file, right? And you saw it on the GitHub page when I briefly showed that. And just move that content over and then run the preview again. Restart the server, because things are cached, I'll show you in a second. But then we can see this is the README rendered using my markdown engine that I'm using. So very straightforward, makes it super easy. I just wanted to get up and running with something so I could show you guys. It also has the ability to output all of these files to a folder such you can do a Jekyll so that you can deploy it someplace. And so in this case, I just did generate site, and you can see the HTML file. This isn't just rendering the markdown live. It's the compiled version. And all this is made possible by this library that I wrote, and starts off at the entry point here where we configure the static site generator, and then we just call start. It's like any other typical CLI interface we would write. Configuration probably looks familiar if most of you are writing Rails or Ruby. It's just a class, and we can yield to, it's like instance eval, basically anything we pass in, like so that these options get overridden, right? And there's some defaults there that I don't want to reproduce. And then from here we go into, when we call start, I think it's start here, it calls parse command, and then it just takes the arguments from the command line and then runs a very, very simple regular expression on that, and then turns that into a class, and then sends the action. Like nothing, what could go wrong, right? If you do happen to get an argument error, I catch it and call help, which is here. It's just a very basic thing. Like every CLI app should probably have this, right? So when we intern this into a class and call the action, it's just another class. Like for example, post new, it's just a class with a method new on it. I'm not using any method missing magic or anything. If it's not there, it doesn't exist, and you're probably typing the wrong command. That's your own fucking problem. We'll look at document. Because this part here is rendering the template, the important thing for generating a file is here, where we just basically grab the file name, gsub it, and then write to this path in Markdown. The body itself is not parsed at all. It's just whatever is given to it, so whatever string you give the body. The template itself is actually using discount. I'll talk briefly about that. It's another MRB gem that wraps the discount C library, which is a Markdown implementation in C. And so I've linked against this library, and there's a MRB gem to do that. And I'm just rendering in a block here. This is probably not the most beautiful Ruby code, but it does the trick. This preview thing uses simple HTTP server and builds my routes for me using the static site. And you can see here where I call site routes. These are just cached, and the documents are just cached. We call toHTML on the document. It's just an instance of document, very straightforward. We can see the routes here where it just goes into uses dir, which isn't actually core part of MRuby. I've used another library here. And select the files, only the ones that are marked down, and then we actually parse them and cache those into some hash. And so generating the site is really easy because we can just iterate over these hashes that are cached. And this is the reason why I had to restart the server, because I just cached these things on start, like the first time you call those methods, because I just wanted it to be faster if I had a lot of pages, which I didn't, and so it doesn't matter. I definitely prematurely optimized. Please forgive me, I'm sorry. Anyways, moving right on. The gems that I linked to, I showed you dir.io pack. So when we create a build, we want to link to these gems, and we can just link to a GitHub location or a repo. I know Go kind of does something like this, in that you can just give like a source location, it'll statically link that for you. MRuby will do this as well, as long as you're using config gem. I showed you how it grabs all the gems you link against. And then here we just link to my gem that I created. And so this file is just any other gem specification in Ruby. We add our dependencies for runtime, and then you might have noticed why there isn't like exactly one-to-one. It's because some of these also add dependencies to the runtime for me, and I'm not sure exactly which ones. It's kind of like a dependency graph hell, but it's all statically linked, so YOLO, whatever. The rake file I'm using to build MRuby is super important. I've passed in the MRuby configuration after I've downloaded the archive and expanded it, and then when I use rake, I'm specifying my build configuration to MRuby, to not use the default one that I showed you, to use the one that I just wrote. And then we can run the tests. We've always passed in MRuby config so that it knows to use this file for me. And I can specify other targets But basically, in other cases, when we get to this point, one example we can look at for that is the regular expression library that I'm using, which is Oniguruma. And it's basically like the regular expression engine that we have in Ruby, but it's just linking against Oniguruma. So I use it here in my library. As I showed you, there's literally one regular expression. And so their specification adds the library to the linker, but you also need to tell it how to get that library. So in your specification, they're using a version and they're telling it, this is where the header file is, and then it continues to make a file dependency on this header file. And we can see here where it extracts the archive for that library. It's literally on GeoCities. Probably skills, I don't have any idea. And then extracts it for me. But after we get that, then we need to compile it so that we can link against that header. And so we have the header dependency, and then we have the library dependency. And what it does is passes these build commands along and then runs auto tools and configures and makes. And then it links that library out to the CC and the linker for include pass and library pass. I added support to the discount library so that I could statically link discount, the C library, to the gem, because I was running into portability issues when I wanted to deploy this thing and run it on Travis or something. I need to also install the header files on that system. So to get around that, we should statically link our dependencies and avoid dynamic links when possible. It's not a part of the MRuby way. And this patch is very straightforward. I started by using Open3 because we're just running straight Ruby. We're not using MRuby to build this stuff, so we can use other gems like Open3, and we can run commands through that. And so one such command that I did was configure and make. And then I also have the clone command for getting the source. And so I do that there, and then I just link against the discount dir file so that the library pass the include can find that. Basically, there's no require. The include is your require. So you need to tell the compiler where to look, right? It's just like load path in Ruby, and include is your basically your require at that point. We can do cross-compilation. Basically, we're just specifying different targets, and we can override flags and compilers. This is from the wiki. I actually did this using AppFair, which is a Windows CI environment, and I installed MinGW so that I could cross-build binaries. You could do this on Linux as well, and basically you just specify a build config file and just override the linker commands. So I can override the binary that comes out, which is to be an exe, and I can do the executable as exe, and I can use MinGW, the GCC port, and the archiver for those commands, which will just override whatever MRuby does. We can see here in the Oniguruma library that you're using this when passing along, so that you have to keep that chain going, and this is the most difficult part of this process, is making sure you're linking things properly and passing on the right environment variables. You can override a bunch of stuff. This is all on the wiki, the linker as well. There's a bunch of stuff you're going to have to get into. But all of this really reminds me that this is all built on top of Rake, literally, and Jim is amazing, and I miss him. And so thank you, Jim. There are some caveats involved in this. I'll just go briefly over this stuff. Compiling requires Ruby, I showed you. Packaging, you should worry about what you're doing with your bytecode. It should be a part of your compile process and linking in the interpreter so that everything is statically linked. And dependencies are unbounded. Like I said, if a dependency requires another library that I don't necessarily know, I'm not going to find out until I compile it. The VM introduces some overhead. We're going to go into these topics real quick. There's no global interpreter lock, and it uses a registry VM architecture, so there's some trade-offs involved in that. When I talk about overhead, what I mean is there's costs for VMs, and it's recommended to run one VM per thread because starting many instances at once is really slow. And this reason why there's no global interpreter lock is because there's no mutual exclusion because the VM is thread unsafe, and thread safety introduces even more overhead, so they want to limit that even more. And the key to this is to use multiple VMs. This to solve this problem. And it's possible by the registry VM architecture which in theory it allows you to have infinite registers or instances, providing there's enough room, right? So if you want to run a VM per thread, if your OS only gives you 2 threads, well, guess what? You only get 2 VMs. I said there's no require, there's also no eval. And if you're going to do block invocation like I was doing in the configuration setup, you should do that in Ruby and not in C. And the garbage collector requires write barriers everywhere so that it can be more efficient. There's some other really weird quirks, like you can only have 1024 local variables in any given method, and string literals are limited to 1024 bytes. This is just for like optimizations for the VM so that it can be built on smaller things. Lua has similar quirks. The adoption rate is pretty bearing. I mean, I haven't seen many people talk about it outside of Japan, and searching for mruby docs is really hard. I actually had the pleasure of talking to Mats before I gave this talk and just asked him a ton of questions. Not everyone can do that. Not everyone has access to Mats like that. So it's super important that we try to fix this. The target audience is embedding. I know a lot of people are concerned that if that's the only use case, that it's not good for other things, but I think that's not the case. If you look at what other people are doing with Nginx, they're embedding mruby into this web server that's HTTP2 compliant, and it's called Trusted, and people are actually using this in production. It's using a HTTP2 module for mruby that links against NG-HTTP2, which is a C library for this implementation. I also have a really quick introduction to embedding into iOS. If we have time, I can get through this. I just said hello world Ruby on Rails, and I created like a very simple iOS app to do this. I cheated. I used a CocoaPod, which builds mruby for me using the SDK, and then I have a view controller that outlets to this action and embeds mruby inside of it. So when I'm clicking this button, I'm linking it to say hello. And what say hello does is actually boots up the Ruby interpreter and then generates a method for me. And using the text, it converts that. So it takes the text out of iOS, converts it to C, then sends it to mruby, converts that to an MRB value, and then converts it back to C, back to iOS, and then says hello. Like, this method is very straightforward. It just takes a C string and then basically does the same thing for us, like MRB value, Ruby string from C string, right? And then just concatenates them using MRB and returns that so we can get that value back. Got it. All right. So there's some other cool things that people are doing. Sid Meier's Civ 5, they used it. People are working on a just-in-time compiler, which is really cool. Mats wants to focus on this, improving VM speed, refactoring instance restructure, improve hash table performance. That's all the time I have. Thank you. Enjoy the rest of your conference.
Thank you, Zach. mruby is fantastic. You should talk to Zach more about it. The iOS thing looked particularly fun. I'm sold. Yeah, that was actually 40. We did give you a bonus 5, and you went over that too. So speakers, you'll have a timer down on the left if you need to find out what time it is. We are going into a break. I have one special announcement, and that is today's theme of programming is actually code harvesting, code farming, planting code, and picking up those plants. I'm wearing my coderalls. Some of my peers at New Relic have seen the coderalls. If you have any questions about code farming or what it means, or if you're a speaker, I expect, of course, you'll work the theme naturally into your talks. That'd be great. Given that no one has heard of it before now, and I invented it yesterday in my head. The theme of the first day is code farming. Go and have a break and talk to your peers and make some friends.
How do I get back home to the sunshine? Tell my family I love them so. There's a drink out here that reminds me of moonshine. There's something out west that won't let me go. But how do I know right from wrong, dear? good folks tell lies to get by. It rains 364 days a year. On the other day, the weather's fine. Not a lot stay to die. There's a lot about this place that gets me down, dear. But there's plenty more that gets me high. Stopping by, I think you might even fall by my side. I only mean to deceive. Never listen to me, never listen to me. Follow my light. Follow my lead, never listen to me, never listen to me. Fall by my side, I only mean to deceive. Never listen to me, never listen to me. ride these waters dark and dusty. So ride my people, ride. with your muskets aimed at the falling rain, 'cause the city ain't no place to hide. Oh, my sisters in the boat behind, baby, 'cause the crime my lover's mind is made, and I think it's time to get on board. I left my home and all my money to wrestling with the wind. On an ongoing wing, gon' cross the ocean, 'cause I heard that it's a heck of a swim. Oh, my sisters left to be an Indian's bride, baby, 'cause the times, maybe 'cause the tides that rise. Ain't it funny how the time just flies? Oh, Lord, don't you think it's time to get on board? Well, my gasket's blown.
It's the 9-minute warning.
Okay, where I was made, I know.
Baby, remember on the bus and my hand was on your knee. When you love somebody, it's hard to think about anything but to breathe. Baby, I am the cub who was washed out in the flood. When you love somebody, bite your tongue, all you get is a mouthful of blood. Okay. Baby, remember on the bus and my hand was on your knee. When you love somebody, it's hard to think
This is your 5-minute warning. We have 5 minutes until the festivities commence. 5 more minutes to drink.
I am the cub who was washed out in the flood. When you love somebody, bite your tongue, all you get is a mouthful of blood. Here we go. Baby, I'm the cub who was washed out in the flood. When you love somebody, bite your tongue, all you get is a mouthful of blood.
Before she met me, she told herself to wait 5 years. And after I met her, her teacher said best wait 5 years. I asked my neighbors, they said it's wise to wait 5 years. I tell the friend how I'm feeling, and this made her sigh. 'Cause she fears that no man will ever desire her so bad. How dare I feel this and do not but sit on.
Okay, we got about 1 minute left. Take your seats, please. If you're going to sit at all, you're welcome to stand. Standing is healthier for you. I don't know if you've seen that. Standing desks are a popular thing now. Standing conferences are all the rage. We're going to take all the chairs out next year. Just standing. Yeah, woo, standing. I see, you guys think that you're just sneakily like chatting on the side. I can actually see all of your faces talking right now. Go to your chairs, hello. Go sit down, please. I have some really important things to talk about while all of you are finding your seats. Does anyone know of Sticker Giant? Has anyone heard of Sticker Giant? Sticker Giant is a fantastic sponsor of Ruby on Rails. 2 years running now, they have donated these beautiful stickers, and this year they are kind of incredible. Not only did they donate all of the stickers, but then they donated some upgrades for the stickers and a larger quantity of free stickers. I don't know how you continue upgrading free with more free. But they're amazing. Sticker Giant is fantastic. If you need stickers for your conference, you should go to them first. And instead of us, pay them a lot of money. That would be great, because then they can continue to give us beautiful stickers. They're in the back up there. If anyone wants a sticker, I'll try and carry around a pile with me. But it's the little badge art that we have, and it's on a clear sticker, so it looks really pretty on your MacBook. They're fantastic. The name, again, is Sticker Giant, if you have any questions. So, I would like to introduce our next speaker, who is Sing-Wei Su. It took me several tries over the course of knowing Sing-Wei to get that name correctly. I'm really good at mispronouncing names, as it turns out. You will recognize her because she has too many H's on her name tags. In fact, all H's, actually. Her Twitter handle, I believe, is so many H's, if I am correct. So Sing-Wei is a Rubyist. She works primarily in Rails these days. She is particularly interested in parsing, probably in no small part due to the fact that she speaks 4 languages. Can anyone guess the 4 languages? French is one of them. Somebody already, there's a spoiler in the audience here. Somebody already knew all the languages. I'll give away the other ones too. Yes, she speaks Mandarin, Chinese, French, and English. If you speak Cantonese, do not talk to her. You are not welcome here. She is a Mandarin speaker, okay? She'll probably be nice to you anyway if you try and speak some Cantonese with her. And there's one last language that's super tough to guess, actually. Ruby, Dutch. Oh, cheater. You're such a cheater. I know you're cheating. Nobody just guesses Dutch first try. It's not a thing. So, Dutch, Chinese, English, French, and Ruby. And she's here to talk to you about parsing. Please, a warm of applause for, or round of applause.
Hello. Wait, is this on? There we go. Okay. Hello. Oh, good. Yes. Okay, good. So my name is Sing-Wei Su, and as Jonan said, it doesn't look anything like it sounds. A lot of H's that are all silent, so I go by so many H's. And today I'm going to talk about parsing. A little explanation about the title of the talk. I probably started first thinking about parsing when I was teaching English as a foreign language, and had to explain things like why so many words in English have multiple meanings, like flies. So depending on the meaning of that word, the sentence can go in very different directions. So when I first started looking into how computer languages are parsed, I noticed that there's actually a lot of similarities in how humans parse sentences in the language they hear and read every day. So I'm a relative newcomer to the programming world, so I never actually learned about parsers or compilers or anything in school. So I actually also have an alt title for this talk, which is How I Accidentally ate Computer Science, and so can you. So, of course, it's not going to be a comprehensive talk on all parsers, but I wanted to share how I came to learn about them because, honestly, I really had no idea what they were until a couple months ago, and I feel like I came into them by accident. So rewinding a few months back, I had just spent a year going through a program called Android Developers Academy, and where I learned, among many other things, how to build Rails apps, and we were churning out new apps every couple of weeks. And one day I got curious about how things actually worked underneath all of that Rails magic. And specifically, I was trying to figure out how routing worked. So I went to GitHub and started poking around some of the Rails source code and came across a file called parser.rb. And I was like, okay, cool. Like I'd written like a kind of mini parser to better understand like what a language interpreter does before. So I thought I probably knew what it would look like. And it turned out it was nothing what I expected. It's like, I didn't even recognize this. So I was like, okay, I have to look a little bit deeper. And I saw this file was actually generated using a different file called parser.y. So I was like, okay, let's look at that. Still didn't make any sense. And barely even looked at Ruby code, like any kind of Ruby code that I recognized. So I was trying to figure out the best way to get myself to learn this. And I've been told that a great, if terrifying way to make yourself learn something is to submit a talk on it. So I was like, okay, sure. What's the worst thing that can happen if I submit a talk? Either I get accepted and I have to talk about it, or I get rejected. So it turns out the worst thing that can happen is to get rejected and accepted. So thanks a lot, Josh, for putting me through all of that. But anyway, here I am. And to get warmed up to the idea of parsing, let's play a game with some audience participation. I hope most of you have played it before. It's where I ask for a type of word, and you have to fill in the blank to make a sentence. So I need a verb. Anyone? Okay, drink. No audience plant or anything. So the young man drank. This seems like a perfectly valid sentence. If you can all remember middle school grammar lessons, you can diagram the sentence into a subject and a verb, where the verb is drank, and since all sentences need a subject to actually do the verb, we know that the subject is the young man, so it makes sense, right? But are there any other possible sentences that could have started with the young man? So for example, the young man did something, so I need a noun and a verb. We can use the same verb drank, but drank what? Beer. Beer. Great. Didn't anticipate that one at all. So also grammatical. This time, instead of just subject plus verb, we have subject plus verb plus object, which abides by the rules of English grammar if we interpret the young man as subject, drank as the verb, and the beer as an object, which we know makes sense because objects are nouns. But still, can we come up with even more possibilities for a valid sentence that starts with a young man, either using subject verb or subject verb object? So for example, can you fill in this blank with a noun? Anyone? Well, you can try the boat. So the young man, the boat. Is this grammatical? Or is like the young man beer, is that grammatical? You think not, right? Because you think, based on the previous sentences, we assume that the young man is a subject, and then you have a direct object, and we think, no, this is not grammatical. But it turns out you can actually parse this sentence in a different way. So if we interpret the subject as the young, as in like the young people, we see that it still follows the same rules as the sentence, the young man drank beer, which was subject, verb, and then object. And we were initially led astray because we tend to think of man as a noun, and therefore in the previous sentences as part of the subject, and not a verb. And so this kind of sentence is called a garden path sentence. Garden path sentences are sentences that contain a word that can be interpreted in more than one way, so that you think the sentence is going in one direction, and then it pivots on that ambiguous word and goes in a completely different one. So time flies like an arrow and fruit flies like a banana is an example that follows that pattern. Another example is the man who hunts ducks out on weekends, sort of led astray by like thinking of ducks as the direct object. We painted the wall with cracks. We might expect paint or something after with, but cracks describes what's on the wall. When Fred eats, food gets thrown. Mary gave the child the dog bit a Band-Aid. And the woman who whistles tunes pianos. So this kind of ambiguity in sentences can also be seen in hilarious actual headlines, such as grandmother of 8 makes a hole in one. Man-eating piranha mistakenly sold as pet fish. Eye drops off shelf for pharmacies, I guess. Complaints about NBA referees growing ugly. And my personal favorite, milk drinkers are turning to powder. So regardless of the ambiguity in natural languages like English, we can all agree that as speakers of a language, there are certain grammar rules that we are aware of that allow us to make decisions as to whether or not a sentence is a valid expression in that language. So as we've seen with the last couple examples, we know that one possible kind of valid English sentence consists of a subject plus verb plus stuff. Most of us probably did that sort of thing in middle school, and we know that like a sentence diagram tree looks something like this, where at the top level you have the sentence, which can be broken up into its constituent parts. So here the noun phrase and then verb phrase, which can then be further broken down until every word of the actual sentence is added as a leaf of the tree. So in this sentence we have John lost his pants as the leaves of the tree, but the same tree could apply to the young man, the boat. So these kinds of trees are constructed based on grammar rules. The convention used to describe grammars in the computing world is a notation called Backus-Naur form, or sometimes extended Backus-Naur form, BNF. So in the BNF notation, you have a series of rules that together constitute the language, or in other words, can define every possible sentence in that language. There are two kinds of symbols that are used to express each kind of production rule, and those are terminals and non-terminals, which we'll get more into. The basic format for each production rule is that there's a left-hand side, which produces a right-hand side, or can be rather rewritten as what's on the right-hand side. So on the left-hand side, you have a single non-terminal symbol or token, which produces either a terminal or a sequence of terminals and non-terminals. So what does this mean? For example, a super simplified subset of production rules in English, sentences based on what we saw before, might be something like at the top level, a sentence produces a subject plus predicate, and the predicate is a verb plus stuff. So here is an example of 10 production rules that can possibly describe both of the sentences we created earlier, the young man drank beer, the young man, the boat. And these rules make use of 6 non-terminals, sentence, noun phrase, noun, verb, and article, and 7 terminals, which are just the words the, a, young man, boat, beer, and drink. And obviously some of those fall into different production rule categories. So using this grammar, we can start at the top level and keep applying production rules until we generate the full sentence. So we start with sentence becomes a noun phrase and a verb phrase, and then the noun phrase becomes an article and a noun, which in turn hit the terminals of the and young for the article and noun respectively. And similarly, the verb phrase can then be broken down into verb and noun phrase, and so forth until you finally get the whole sentence. So pretty straightforward. The same thing can be applied, the same production rules can be applied to the young man drank beer, but just in a different order. So you get the same sentence so we know it's valid. But what does this have to do with computers? This is just grammar, English grammar. But it turns out the process by which we parse and understand sentences in a natural language isn't that different at an abstract level from what a computer language parser does. So here's the basic flowchart of what happens to your code. You have the source code, which gets passed into something called a lexer or tokenizer, which produces a bunch of tokens. It reads the sentences and figures out like recognizable units. And those tokens in turn get fed to the parser, which in most computer languages spits out a syntax tree, which then your compiler or your interpreter walk to output CPU instructions. Excuse me. Oops. All right, good. So, but of course, most of us don't spend a lot of time implementing new programming languages. But by better understanding the lexer and parser steps, we may be able to see how to use parsers for simpler situations. So rather than a Ruby script, you can feed anything, a log file, a markdown document, whatever, or even just a plain string, into your parser and get some kind of output, which doesn't even necessarily have to be a syntax tree. It could be just a different data structure, or even something as simple as a Boolean. So starting with flexing or tokenizing, all this means is turning your input into a sequence of tokens that your parser can recognize. These tokens can then be matched to the grammar that describes your language you're parsing. So let's look at a really simple example. Let's build a parser that can handle super basic binary operations in math, such as addition, subtraction, and multiplication. The entire language will consist of an integer followed by an operator, then by another integer. So the grammar rules here are pretty simple. We only need 3 of them to describe every possible sentence in our mini math language. The start symbol here is the expression, which constitutes of 3 non-terminal symbols, a number token, then an operator token, and then another number token. And the number token can then be rewritten as any digit, And then the operator token can be rewritten as either a plus, minus, or multiplication sign in production rules 2 and 3. So here's a really simple implementation of a tokenizer in Ruby using the string scanner library and just regular expression matching, pretty much identical to the ones that we saw in our production rules, to grab tokens of either type, number or operator, and then it returns them all in an array. So when we input the string 3 plus 7, we should get a 3-element array as your output tokens. So number 3, operator plus, and number 7. And now we want to pass those tokens into the parser. And ultimately, we want to end up with a tree that looks something like this, so that when you feed it to the interpreter, it looks at the head and knows to execute addition on the left child and right child. So a really trivial implementation of this parser might look something like this. You have a parser that only expects 3 tokens and outputs a tree with a single node containing the operator and the 2 children, which are the number tokens to be operated on, which is really simple. But now, for some slightly harder math. So take, for example, this expression. You have 2 times parentheses 3 plus 7. So with this expression, we need slightly more complicated rules to describe it. Whereas before, our first production rule was expression equals number followed by operator followed by number. Now we have at the top level expression equals number followed by operator followed by expression, where the expression can be then rewritten as either an expression in parentheses or just a number. And then the number and operator non-terminals still translate as they did before in the previous production rules. So we tokenize for saving space, it just outputs the 2 times and so forth. And this is ultimately the tree that we want to build. But how do we tell the parser to construct the tree correctly? So one common approach is to use a top-down parser that looks ahead 1 token to decide what grammar rule to follow. So like garden path sentences, we need to know what comes after the current token to know what kind of rule to use to understand the sentence. So for example, knowing that the young man is followed by the boat allows us to know what the subject and the verb of the sentence are. If you can adhere to a grammar rule when you consume each token, then you're good to go and you can keep parsing. But if you don't, then you hit an error state and then you can't continue parsing. It's a syntax error. So here we start with the first token, which is a number token. Since peeking ahead at the next token, it tells us we have an operator coming up. We know that the only possible rule we can follow is the one that says an expression is a number followed by an operator and then another expression. So we start building our tree with node 2. Shifting over to the next token, we have an operator. Peeking ahead, we know that the next token is a parentheses. And the only grammar rule that has an operator followed by a parentheses is still the first one, since we know that an expression can also start with a parentheses. So far, we're still in the realm of grammatical correctness, and we can keep parsing. And we can set the operator as the head of the tree. So now we consume the parentheses, and we see that the next token is a number. Since we know that a valid expression can either be a number or a number plus an operator plus an expression, we still haven't violated any grammar rules, so we can continue parsing and update the right child of the tree to be potentially expression in parentheses. So then we consume the number token, holding the value 3. Previously we knew we had 2 options, either interpret the number as just terminating into a 3, or as part of the first production rule, which states that an expression can either be a number, an operator, or an expression. So since we can peek ahead at the next token, which is an operator, that gives us enough information to know which rule to follow, which is the first one and not the second one. So now we have the expression, now we have an expression that will turn into a binary operation, and using the same parser, we know that 3 will be the left child of that subtree. So now we consume the operator token and see that it's a plus. Peeking ahead to the 7, we know that it adheres to the first production rule, which tells us we're good to keep parsing, and we can add the plus operator as the head of the subtree. Then we reach the 7. We know from the previous step it has to be an expression of some sort. Look ahead tells us that we have a parentheses, which completes the expression, it completes the rule of expression equals parentheses expression. So now we can build our complete tree. If, on the other hand, there had been no parentheses at the end, then the second rule, production rule would have been violated, and we would not have been able to complete a valid syntax tree. So building from the top down. Looking at the summary of steps we took to build our syntax tree, you might have noticed that we often had to call expression from within an expression call. In other words, the process we went through to parse a sentence was recursive. And since we were building the tree from the top down, this method of parsing is also called recursive descent. This is probably the most common type of parser that people might try to write by hand, but there are a number of problems with recursive descent. For one, the recursive nature of the process makes it relatively inefficient, because you might end up checking a token against every single grammar rule that you have before you can parse it. Or if you're not careful with how you write your grammar rules, you'll end up in an infinite loop. For example, if you have a production rule that says an expression equals expression op expression, then you hit the first token, you go back to expression, which produces expression op expression, which goes back to expression, and so forth and so on ad infinitum. Finally, you sometimes have limitations in the way you can order or write your grammar rules for a language that uses recursive descent parser. In the case of a calculator language like this one, depending on the order that you write your grammar rules, you'll potentially run into issues with associativity. That is, like if you say 2 minus 3 plus 5, how does the parser know whether to give precedence to subtraction or addition? So another approach to parsing instead builds the parse tree from the bottom up. The key difference here is that this approach makes use of a stack that you can push tokens onto until there are enough tokens on the stack to fulfill a rule, at which point they get reduced and popped off. So for that reason, this kind of approach to parsing is also called shift reduce. So going back to our slightly hard math example, here we start with the first token, 2. We push it into our stack for the moment. And based on the grammar rules, we know that 2 is a terminal for a num token. So the stack reduces it to the left-hand side symbol for num. Then we set aside the 2 as a building block for our eventual tree. So then we shift over and consume the next token, which is a time sign. This gets pushed onto the stack, and then we look at the grammar. The rule that matches is operator equals multiplication, so we reduce it in the stack and move it over. Then we shift again and grab the parentheses. We add it to the stack. And since this looks like it could be covered by the rule where expression equals parentheses expression, we keep it in the stack for now and just keep shifting. The next token is now a 3, which we push. Again, applying the first grammar rule, we reduce the 3 to a number on our stack, set it aside again. Shifting over to the plus sign, we add it to the stack as usual. We look at the grammar and know that this is an op token, so our next action is a reduce, and once again, we set it aside. Our next action is to shift. We push the next token onto the stack, apply our production rule, which is num is 7 and expression is num, which recognizes the 7 token and reduces it to expression, and then we set it aside. At this point, the tokens on our stack have fulfilled a rule that our grammar recognizes, namely that expression equals number followed by operator followed by expression. So now the stack takes the 3 tokens involved in the rule and reduces them to simply an expression, which can be shown now on the stack in green. So now our parser knows what to do with those elements involved and can create a subtree from the 3, the plus, and the 7 in the same way that we saw previously in the top-down parser. That's all the reducing that can be done for now, so again, we shift to consume the last token. Again, we push it onto the stack, and now, again, the tokens at the top of the stack have fulfilled another grammar rule, which is expression in parentheses. So since those 3 tokens at the top of the stack fulfill a rule, the stack reduces them into just simply an expression and puts on the stack. And so now on the stack we have left number, operator, expression. But now we're at a state again where the tokens at the top of the stack have met another grammar rule, which is expression is number, operator, expression. This allows the first tokens we set aside to be added to the tree at the proper level, above the subtree construct from the previous reduction. So again, we can reduce the tokens at the top of the stack into the top level expression non-terminal. And so now we've reached the end of our tokens, and since we were able to perform a valid reduction, we know that the input was valid. It was a valid grammatical sentence in our math language, and we can accept it and create the final tree. So those are 2 types of approaches to parsing, top-down or recursive descent, which is, again, most commonly written by hand, whereas the bottom-up, which you might sometimes hear called LALR, and they're much, much harder to write by hand. So unsurprisingly, the more grammar rules you have, the harder it is to construct this parser. But fortunately, there are tools that make parsers for you. These tools are called like Yak, Rack, and Bison. They're called parser generators, and all they need is a grammar file with all the rules that determine the language that you want to parse, and it'll spit out a parser for you, which then you can feed in any input to do the right thing. So those grammar files were like the wacky dot at the very beginning, but now that you're not that the rule for email or a dot like is that into type So, like, and comes back to default. That doesn't work because then you have an infinite number of grammar rules. So, what's the grammar? Thanks to parser generators, you don't normally have to do much more than come up with the grammar, but sometimes the grammar itself can be a little bit tricky. So this particular problem actually reminds me of a logic problem that I'm sure some of you have heard before. So the problem is there are a bunch of gnomes in a cave. They've been kidnapped by an ogre. And some of them, they have their foreheads painted red to be eaten right away, and some of them have their foreheads painted blue to be eaten later. However, the ogre gives them one chance at saving themselves, which is the gnomes are allowed to exit the cave one by one, and without communicating or speaking to each other in any way, they have to sort themselves into a contiguous line with the red painted gnomes on one side and the blue painted gnomes on the other. They don't know what's on their foreheads themselves because the cave is, pitch black. So does anybody know the answer to this one? I know some of you do. So the answer to this one is that each gnome, as they exit the cave, they insert themselves in between the red and blue ones. And if you think about it, this is actually how this grammar ends up working. To use BNF notation, that means a sentence or a statement S is basically an A or a B with another statement token inserted in between the A and B. And if we specify that the statement token can also be nil, then that provides the only terminal that we need that will cover all cases of the deceptively simple-seeming AB language. So remembering that a grammar rule for a regular language can't have a sequence of terminals and non-terminals on the right-hand side, we see that this language already is a context-free language. So, as we've seen, we don't really need that much complexity before you get out of regular expression parsable territory. Because of that, you usually are going to be better off figuring out the grammar rules for the thing you're trying to parse and using a parser instead. This also ensures greater accuracy in what you're trying to parse. So for example, there are a number of web servers that use a parser for HTTP requests, such as Raggle or Jetty, which is used in Mongrel and Java. But even as recently as last week, there was actually a vulnerability uncovered in Jetty, which is again used in Java servlets that prints debug information in the HTTP response, which is bad. So the other thing about parsers is that they're often a much faster way of getting what you need done. So for example, in a web framework, if you use a parser for your routes, then you can build a tree for your routes, which makes your lookup much faster than just a linear look-through. Extra credit points for whoever can tell me the complexity of that. Of course, parsers are hard to write, but thanks to parser generators, all you need to figure out is the grammar. So there were a ton of resources that I used to prepare for this talk, and I couldn't list them all on one slide, but here are two links if you actually want to see an implementation of an actual recursive descent parser. This one happens to be in Python, and stuff for shift reducing. And once again, I'm Sing Wei, so many H's on Twitter, on GitHub, Elfers. I am a Rails developer at CareZone, and we're hiring, so if you want a job, come talk to me. All right, thank you.
Thank you. We have a quick break. We're going to do about a 10-minute break, and you're going to get a chance to get a beer and use the restroom and talk to all your new friends, and then we're going to hear from Terrence Lee. So again, break is for 10 minutes. Let's be back here at, I guess, we'll say like 45. I'll come and yell at you in the lobby.
just like the rest of them.
Stand up there with you.
Yeah. Welcome back, everybody. We're going to get started again here with our next speaker. I want to thank someone. I need an organizer's help. Kobe, who's the artist? What is her name for this? Taylor Rose drew the name tags and the Ruby on Rails art that you have on the t-shirts. Those are bleached into the fabric, by the way, so that pattern won't wash off, which is kind of awesome. She drew all of this art. She drew a custom name tag for me with a one-up mushroom on it because it's my favorite. And she drew all of the art last year. Her website is taylorrosemakesart.com, and if you need some conference art, it would be a good idea to hire probably the best one ever at doing that thing. So again, her name is Taylor Rose, taylorrosemakesart.com. I would like to introduce for you this gentleman in the blue hat here. H on his hat stands for Hon02, which is his Twitter handle, and also Heroku, where he works. That's why he wears the hat, I'm pretty sure. I'm not a sports ball person, but I think that's what it is. So Terrence actually and I have been friends for a reasonably long time. We met at the first Ruby on Rails, which I think was his first speaking gig, and I was impressed because he's a snappy desser like me, so we got along right away. He works at Heroku, as I've said. He also works on Ruby. He, I believe, is the only person to have ever maintained two Ruby versions at the same time, 187 and 192. May they rest in peace. And now is...
Zangief helped me.
Oh, and Zangief, yes. Everyone remembers Zangief from earlier, also helped with that. One of his early Ruby projects when he was fresh out of the bear wrestling mines of Siberia. So he and Terrence worked on those Rubies together, and Terrence now works at Heroku. If anyone has used Heroku, you have used Terrence's code because he wrote the build packs and maintains the build packs. And I'm sure there is more to the build packs than just Terrence's code, but he was instrumental, to say the least. So with no further ado, I want to mention one more thing, actually. Terrence also started organizing a conference this last year held in Austin called Keep Ruby Weird. And Austin, for the record, stole the Keep Austin Weird from Portland. That was a Portland thing. Originally, we invented it because I said it on real video. Now it's known to everyone that Portland invented it and Austin stole it. And
You should probably update the Wikipedia article.
I'm going to go update Wikipedia after this. I got to go to Keep Ruby Weird this last year, and it is fantastic. It is a lovely conference. They have a mascot named Rhodey. Some of you got a preview of me sitting on Rhodey, the other slide. And if you get a chance, you should definitely go to Keep Ruby Weird. It's a lot of fun. Very similar feel to Ruby on Rails, actually. A lot of close people hanging out. So this is Terrence. Big round of applause.
How do I do this? Thanks, Paul. Awesome. Yeah, so this is a picture of Jonan sitting on Rhodey during our socialization practices at Keep Ruby Weird. So this is my third time speaking at Ruby on Rails, and I still get really nervous, so I asked Jonan for help, and he told me to put this slide in to make me feel a little better about it. So I'm here to talk to you about Ruby objects a little bit. When I think about walkabouts, I think of Australia, I guess. That's where it comes from. So this is me at RubyConf Australia. I don't really know what I'm doing, but I'm supposed to be doing a Friday hug. But I'm actually kind of disappointed the organizers didn't schedule me on Friday because I've been able to do that the last 2 times. But I guess I'm going to hope Ernie's going to do it tomorrow morning for me. I am go by Hono2 on Twitter. Like Joan said, I come from Austin, Texas. We have really awesome tacos. Joan will vouch for me. I picked him up at the airport when he came into town and took him to some pretty awesome tacos. We also have really good barbecue. I don't know if you've heard. So we took a bunch of the speakers to Franklin Barbecue, which is this really famous barbecue place in Austin. And this is a picture of Jonan not getting into the barbecue place because it's like a 5-hour wait to get in. And this is a picture of the barbecue. But we did eventually let him in to have some barbecue. And like Joan said, I have a blue hat. I don't really know why I'm known for it. I guess I just wear it all the time. And it does not stand for Heroku or Hono2. It's actually just a college hat, but they don't sell it anymore. And you're probably going to ask me what I'm going to do when I lose this hat. I don't have a real answer. But I do have hat stickers, some of them left. So if you do want a hat sticker, feel free to come up and just talk to me. And I'd be more than happy to give you some if I have any left. I work at Heroku. Happy to have been there. Been there for almost 5 years at this point, and they let me work on open source and a bunch of Ruby stuff, maintaining Ruby 197, 192 with Zach, and work on some of the bundler stuff and a lot of other things. So I'm super appreciative of our customers and the chance to be able to do all that stuff. So if there's anything actually broken on Heroku related to Ruby, that is my fault, so you can come yell at me about that. And one of the awesome things is I get to work with this guy, Richard Schneeman. I don't know if you've heard of him, but he's done a bunch of stuff. He just got commit to Rails recently, and super, he just passed his 3 years at Heroku, so super happy to work with him. And if you didn't know, Ruby Heroes vote ends in 4 days, so you should go vote for him for all the work that he's done. I think he's done a patch to Rack that has improved memory consumption by 5% across all Rack apps out there, so just one of the many things he does. In addition, you should vote for Zangief as well. I told him I would be his Ruby Hero campaign manager over the last year, so in every talk that I've given since 2013, I've included this slide of him for, all the work he's done in Ruby, but also maintaining RubyDoc and many other things. I know he spends many nights and weekends working on stuff, so we don't have to. But on to my actual talk. I've heard a lot of Ruby talks about introspecting and doing things in Ruby. Davey's given an awesome talk about benchmarking, and one of my good friends just benchmarks everything against the Fibonacci algorithm. But I'm not here to talk to you about Fibonacci or benchmarking. I used to do some Java development, and I've done some stuff with JRuby, and I'm super jealous of their tooling that they have, the enterprise tools that they have, but you can get these cool graphs of stuff running in production. You can dump like your thread stack and stuff and like load it up in another process from production, and I kind of want to explore and talk about some of the tools that we have in Ruby that aren't quite there, but that are getting us towards something that is better what you can do with your Ruby applications. So I'm here to talk to you about TracePoint, ObjectSpace, and the Allocation Tracer gem. Basically, Kira came and talked to me and said, she talked on to TracePoint. That said, that at least introspection that understand and outside of production. So for that an event called and we were to step set begin the name. But one that I also have only for actually wrote had on whole rack kind of see. So basically, goes through the number of classes that are created, the number of methods that are created, and then the number of methods that are dispatched. And I kind of just wanted to compare what that would look like across like a simple Rack app, a simple Sinatra app, and a simple Rails app that had very similar code. So here's that TracePoint middleware. It does a bunch of stuff. If you go to this gist, you can see the actual code. And then here's my simple Rack app, and I'm basically just requiring it right before and then using it. And then all I'm trying to do here is print the Ruby version out. And how many methods or classes do you think this actually calls? 500. So someone said 500. 5,000. Over 9,000, so like JRuby 9,000. So this actually only calls one, it instantiates one class, the one we defined, calls one method, has one method that's called, and dispatches that single method. So I did the same thing for Sinatra, like very simple hello world, pretty much the same thing. How many classes and methods do you think are on this? 37. 37 classes, 37, just 37 all around. 5,000. So this is actually, just to do a hello world Sinatra app, is 43 classes, there are 155 methods used, and then 548 method calls are actually dispatched. So like it is way more just to even get like a hello world Sinatra app. But of course the fun one is when you get to Rails, right? So this is my very simple Rails like hello world that I tried to mimic the same thing. So we have a very simple like view and controller. How many classes and methods do you think this is? 370,000. Wow. I don't think I'm running that version of Rails. So the answer is 361 classes, almost 1,200 methods are instantiated, and then 8,600 methods are dispatched. And so this is basically an order of magnitude more than Sinatra, right? Like 43 versus this. But this is just an example of like cool things you can do with TracePoint. The fact that you can actually like have a method that's called on various points in your code. So just an example of, I didn't think this was particularly useful besides just introspection, but like you can imagine building something that is much more useful based off of this TracePoint information. So in that TracePoint middleware, I also printed out a JSON of basically those classes and then all the methods that are called, and then how many times they're called, just to calculate like that summary information, right? You have to generate this hash anyways. And so I just saved this to a JSON file. And so here's an example of that output. And so for this Sinatra example, I basically sorted based on the number of times every method is dispatched. So E or B in Sinatra is the thing that is called basically the most when you're doing this Hello World Sinatra app, which I thought was just interesting. So based off this, potentially you could maybe optimize like certain calls or reduce methods that are being dispatched. But just, again, interesting information that you can introspect in your Ruby app, stuff that I haven't really dug into before until like the last year or so. So that is TracePoint. And so it allows you to essentially insert code that allows you to run stuff on lines inside of Ruby, right? Like when events are called. So the next thing I want to take a look at is ObjectSpace. And so ObjectSpace has an API. I think the first time it was introduced was in Ruby 1.9. I could be wrong about that. And then there was the .so that was added later. But they've been slowly adding more and more stuff into the API. And so you can do count objects, which will give you the count of the various objects inside of Ruby, which can be interesting to look at when you're trying to analyze like object counting or memory information. You can iterate through the whole graph and kind of walk through every single object. So this was just code I wrote. I wanted to boot up a simple Ruby application that really didn't have anything and then basically require JSON and see like how much stuff is there in this thing. And so I'm using each object to count through the objects and then sorting them. And as you can see, like when you're using JSON, like you're getting a ton of strings like being pulled in, right? So again, just interesting information of like the kind of objects that are being instantiated and the counts and things you can do with really basic stuff inside ObjectSpace. Like this code is not very complicated. But again, to note, like if you're walking through the whole object graph on a real application production, that's going to be a really expensive hit. So don't like litter this code in your production. So there's a C extension that is part of the standard library called ObjectSpace SO that gives you access to more stuff. And one of the main things that's in there is the Allocation Tracer. And so allows us to do stuff that is similar to TracePoint. So if we require ObjectSpace up top, this actually requires the .so file. And then we can again wrap this, we can call trace object allocations and then wrap this around code we want to trace. So when we start trace object allocations, it is doing a bunch of work behind the scenes. So again, it's going to slow your code down, but it allows you to examine a bunch of things. So this is another alternative way to kind of look at similar information that you would get from TracePoint, but just using ObjectSpace. So in here, I'm looking at the source file, I'm looking at the source line, the method that is actually being called, and then I want to look at the class path, the class name of what's actually being used here. So given this, this is the output that's just returned for that same thing. So we're not getting all of the class inheritance thing. We're just seeing like the object being counted here. But when you start using this stuff, you can actually start counting objects. So I started just going through and building a simple thing that would just walk through each of the objects and kind of count how much space is being consumed. And this is just like a really short example. So creating a struct to kind of hold all this information, and then I'm defining a method that is going to walk through each of the objects and then essentially store that information as struct and then use it later. So analyzing that same code or a similar code and then walking over it, and then we want to then sort it, and we see that for each of these we can see where in each line in the source file it is, what the method on the class is, and how many bytes is being consumed. So this mem size of in ObjectSpace is a rough estimate, so it's not an exact count of the objects that are being used there. So I know Sam Saffron did a bunch of work, and he does something similar, but does a lot more other things inside his memory profiler gem. So you can go through and run this. And when I was talking about Richard and his work before, he actually went and ran memory profiler on some stuff in rack, and that's how he found all these string objects being allocated. And so there was a patch that he made to rack where he looked at basically these strings and constantized some of them, and it gave basically a 5% memory savings just by doing that work, by reducing the number of string allocations being done. So this is stuff that you can definitely do in your current application to actually do memory savings and see like where you're leaking objects or creating a lot of objects that you might not actually be aware of. So the next part of this is the Allocation Tracer gem. And so this is a gem that my coworker Koichi made. And this is built off of a bunch of stuff inside of the ObjectSpace API, but kind of wraps some nice things around it. And so you have to gem install it because it's a gem, or add it to your gem file. And then I made up some algorithm to kind of analyze like the object allocation in it, so we can actually have some data to play with. So this simple algorithm, I think we create a pivot that is halfway through, and we're basically like swapping elements from the beginning and end of the array. Pretty simple. And then we have some large array that we're passing through to this method. So ObjectSpace Allocation Tracer is off of ObjectSpace, and basically like a similar pattern. You're just calling trace on in the code block that you want to analyze. If you call trace without a block, it will just start, and then at the end you can basically disable it as well. So we're just wrapping this around the code that we're doing, and this is the output that we get. So just to kind of quickly walk through all the things that we're returning here, you get the file name, the number, which you should be used to seeing at this point. And this first number is actually the number of objects being allocated on that line. So this is all the objects that are being created for this specific line, which is actually pretty interesting information. So if we look at this code from before, this is every single line and where every object's actually being allocated. So pretty interesting information. In Ruby 2.1, we have the garbage collector that moves stuff into old objects, the generational GC. And so this actually tells you the number of objects that are promoted from new gen to old gen. So it helps you analyze some of the work that the garbage collector is doing. This gives you the age of all the objects at that point in the source line. This tells you the minimum age of all the objects, and then you have the maximum age, and then you have some mem size without the R value. And so this basically, R value is basically like all the Ruby objects that you're creating. So like you have R array, R string, and stuff like that. So it doesn't include any of those things. But I'm not going to go into too much detail into that. Pat Shaughnessy, if you search, has an article that talks about some of the stuff when he talks about the whole like string and 23 characters long and why that's optimized and whatnot, and he goes into that a little bit more. Yeah, and he also has that great book, Ruby Under the Microscope, as well. I would recommend anyone who's interested in internals to go and read that. So if we go and like look at the output now that we know what each of these columns actually mean, we see on line 15 here that we're creating 10,004 objects. And that seems like kind of on par of like what we're seeing here. We set n to 10,000, but there's like these 4 extra objects that we're creating, and we don't really know off the top, like at least I don't really know off the top of my head, like what those are, what's actually being created. And then we also have on line 7 here, which is this multi-assignment, like we have 5,000 objects being created. And that's like, I guess like I'm somewhat surprised by that, but you know, like n is 10,000, so I guess like on each assignment it's creating some type of object for each iteration through that loop. And we can, to kind of dig into more information, Allocation Tracer allows you to actually set up the keys that you get in the beginning. And so we have the path in line, which is what we're already doing, and you actually can pass in type, which allows you to see, to break it down to, it will separate into each type that's being created. So if we run through this code, we actually get this output. So it actually splits it out into, so we have more lines than before because it splits it out into each type, and because that's what we're keying off of. So from before, we had those 10,004 objects, but now we see we're splitting up into, we have a node type, so a data type, we're getting an array, and then the 10,000 strings, which makes sense because that's like the size of n. So you can kind of dig into that a little more. And the other thing that's really interesting here is that we have this array type. So we know that, now we know that on line 7 in that multi-assignment that we're actually creating 5,000 arrays, which is kind of surprising. Like that's not what I would think necessarily in that multi-assignment. So in that code, that's line 7. And if we actually change the code to this and we rerun Allocation Tracer and we print that out, we actually see that that disappears. So like you can definitely like analyze the code and try to optimize certain cases of like when you're doing object allocations that you might not be aware that you're actually doing. So I actually, like Koichi sent me notes about like this whole thing, and this was an algorithm that he sent to me like on like using Allocation Tracer and actually like seeing how it can be actually useful. So what happens here is that in the multi-assignment over here, we have, since we're multi-assigning inside of arrays on the left-hand side, like an index on the array, that is actually a method call, right? Like you can override the brackets, and that means in Ruby that there potentially can be side effects that happen. So inside of Ruby, that means that when we're doing this assignment, we have to create an array to store the values on the right before assigning them onto the left, because the execution order actually matters. If we were to actually just have like X and Y on the left-hand side, and we ran the same exact code, you would not see the array being allocated in the code. But since we're doing method calls on the left-hand side, we have to care about the actual assignment, which is why these arrays are being created. So if we uglify this a little bit and split this into 3 lines instead of that convenient 1-line method, we see that the actual objects for that array disappear. So that's an example of stuff you can do that's kind of neat with Allocation Tracer. You can definitely introspect into a bunch of things. The gem actually does a lot more things, but I didn't want to dive into too many things here into this talk. So I guess I ran through this really quickly. So in conclusion, we actually have a bunch of tools that we've been working on in Ruby core to help you analyze and debug your Ruby application. We understand that it's not as nice as like running something like JVisualVM, but we are working on hooks and things to help you introspect your application better. And if you have ideas or things that you actually need that you can't do right now, we're open to feedback on either working with you to add those hooks in or talking and discussing like what is your use case for doing that. So there are great tools out there in our ecosystem right now, like New Relic and Skylight and other things that allow you to analyze performance and other things in your application, but they don't really help you necessarily drill down all the way inside the actual Ruby code. They can help a ton with things like database queries and other things like that, but you definitely want to be able to dig out like these tools in your have these tools in your toolbox to basically run against your code to help introspect like parts where you're actually doing a lot of allocations or you're noticing a ton of that stuff. Because a ton of object allocations mean that you need to do more GC, which obviously slows down your app because you have to stop the world for that, for MRI. And that's kind of all I had for my talk. Are there any questions? Yes. I believe, so Tim asked about how the block allocations affect, how they're affected when you're using threads, like if you create a thread inside of that block, like does it actually run that stuff inside that thread? Is it local to that thread? I don't actually know the exact answer. I don't know if you know. What? They're local? Yeah, so I guess they're local to the thread. Yeah. Yeah. Yes. Awesome. Well, I guess that means it's lunchtime.
It is not just lunchtime yet. I have a couple of announcements before we go to break. I want to bring Carrie Miller up here. Where's Carrie? Yeah, Carrie! Carrie is also a longtime Ruby on Rails attendee. And I have a mic for you.
Oh my gosh.
Tell us about a thing, like if you want to and stuff.
It doesn't actually fit in with the theme of the conference, unfortunately, or today's theme of farming. But how many people here have heard of DevChicks, a mailing list that we have?
Everyone, Ruby 2015. Great. Yes. This conference. Fun. So wrapped up in that institutions are behind the scenes. Well, round of applause. I want you all to meet me. He is Amy. Actually, computer. Tim. About assorted nerd. I love a good something very around.
And software estimation. When I entered, I did not be part of expect was been way off. So I'm going to talk about if I can get my mouse back. Well, maybe not. Today I'm going to talk about some estimating games that we should all not be playing. Yeah, you would think, and that was what I was able to do this morning.
There we go. And now you can scroll.
Thank you, Jonah. Jonan. So, luckily there are no names in this presentation, so I won't be flubbing anything like that. Along the way, I'm going to give a short introduction of why estimating helps our project succeed. I'll talk about the ways we estimate and our existing vocabulary for talking about our process. Then I'll introduce a compendium of bad estimation games and wrap up with some thoughts on more accurate estimating. So why do we estimate when it's so tough to get right? At best, estimating seems like an organization's process of being increasingly less wrong about how long work will take. We want our communication about the future to go from something like this, maybe something like this, to something that looks like this if we're in a agile-ish workplace. So these numbers would represent the comparative work that would be needed to complete a chunk of work. So a 2-point story would be twice as much work as a 1-point story. And finally, we'll possibly want to get to something that looks a little more like this. But that date can be so wrong sometimes. What's the point in doing it all? Well, as programmers, we do it to get enough information into the hands of the people we work with that their business or organization can be run successfully. Put another way, given that we intend every piece of software we work on to be beneficial to our employer or our clients' end mission, and ultimately to our users, we want our success, well, our success does depend on our coworkers knowing enough to make those time-sensitive decisions that make our product work. What features we deliver that will have the most value to our users varies based on how long they'll take. So a calendaring feature, for instance, might be a great investment if it takes only a week, but a really bad one if it takes a whole year. In addition, decisions like when to hire a new developer or when to launch the marketing campaign can't be made without knowledge of when we might finish our work. And just like programming takes time, marketing and promotion campaigns have a long lead time, which is why we often need to deliver something as valuable as this, which can turn into something as problematic as this. There's only one character difference here. You wonder why it's such a big deal, right? But even if our estimates do turn into pseudo-deadlines, that's no reason to ignore the power of estimation. Without that estimate, the people who shepherd our products to our users wouldn't be able to make decisions today that impact August. And sometimes that's the difference between the success and the failure of an entire business. And that, of course, sets our projects up for failure. So in addition to providing a timeline, estimating also improves communication about the work we do. It allows everybody to make better decisions. So for example, we might be looking at the most beautifully written, most spec'd out feature in all of creation, with comps so clear they could make a programmer cry. We can visualize already how users are going to interact with this application. And from the feature requester's point of view, they might say, well, this is a house. It's pink, it's got some nice little red flowers, and it's like all the others on the block. And yet it's only when we start estimating that it becomes clear that what we're actually building, if we're building something that's exactly like everything else on the block, is the Starship Enterprise. Because of course, the stakeholders' pink house with red flowers is going to fly. I mean, where else are they going to raise their children but the final frontier? Everybody else's houses fly. So in the same way, if we're talking about a nice little story where we restructure some payment forms for usability, adding a few small features that all other competitors have, we might also, at the same time, be talking about a massive feature with back-end rewrites, since, of course, we roll our own payment processing. That's a good idea, right? We have to mention software. A good way to communicate scope required. They clearly signal that if you want to build your pretty little pink house with red flowers on top of the Starship Enterprise, that what we're building for you is the Starship Enterprise, and oh, by the way, a nice little house. So I've talked briefly about how valuable estimating is to the products we build, and now I want to talk about how we estimate and our vocabulary for talking about estimating. So the estimation process is different in every workplace I've worked at, and I'm sure we have a bunch of different processes represented today. As all of my work has been done in small a agile workplaces, this part reflects that frame of reference. So pardon me if this does not reflect your experience, but the rest of the talk will. On the teams I've worked on, we try to talk first about size and not time. It's really far easier to have a constructive conversation about the amount of work to be done than it is to have a conversation about the precise time it will be completed. A corollary to this is that we want to use comparative estimates and not absolutes. We want to say that this story is a 5-pointer because it's larger than the 3-pointer we're working on right now, but it's also about the same size as the 5-pointer that somebody else just completed. As humans, we are far better at saying this thing looks like that other thing than we are at saying this thing is 100% absolutely this thing. Whether we have to determine whether one thing is absolutely small or absolutely massive, or whether it's absolutely a dress that is blue and black or absolutely white and gold. Next, we want our process to emphasize historical performance and not guessed timelines. We want to be able to say that historically this team has completed 45 points in 2 weeks, and not that we think this chunk of work will be completed by the end of March. Even if those two statements actually end up with the same consequences, we want to be looking at historical data, not at guessing. Finally, we want our process to include times for discussing how to improve estimates, not recriminations for missed deadlines. So if a 2-point story ends up taking about as long as a 13-point story, and that happens consistently, we want to take this as an opportunity to learn about how to improve our estimates, not to say everybody needs to work 80-hour weeks from now on to infinity. So when we talk about how to bring these goals into a reality, many of our processes descend from this game of planning poker. Planning poker might be somebody's ideal of how estimation happens. And so the rules end up being pretty rigid. So a moderator runs the meeting, and each story is introduced by the moderator. Everybody has a chance to ask clarifying questions. They come up with an estimate on their own. All these estimates are revealed simultaneously. our high and our low answers talk. There's a round of discussion where you can ask questions, ask why you estimated high or why someone estimated low. And then you repeat rounds of estimation until you get something that looks like consensus. But because this is relatively rigid, it ends up, our processes often end up deviating or starting from a place that's completely separate from this, even though a lot of them look a lot like planning poker. Either we've added a bunch of house rules or we've just taken a whole bunch out. Still, this game is a key part of how we often talk about what good estimating looks like. So how do we talk about the weird, uncomfortable moments if we don't have the structure that used to be there? Without those rules, our teams don't necessarily have a way of circling back and checking in with ourselves about how our processes are going. We can't say, hey, you just broke a rule, right? We have to talk and make up a vocabulary about talking about weird dynamics that can start creeping into our workplace. So I wrote this compendium of bad estimating games as a silly way for a team I was on to begin talking about how we estimate. And so having talked about why and how we estimate, I'll jump right into the compendium of bad estimating games that we may all have played at one point. So, solitaire. Solitaire is when one developer estimates work by themselves. Don't do it, right? Seems pretty simple. Just say no. I think it's pretty commonly accepted that we should have a few people looking at requirements before we decide on an official team estimate. And we've all had times when someone, whether during or outside the estimation process, thinks of a tough challenge that we forgot that we would face when implementing this feature. And that knowledge leads to a better estimate. But it's really hard when you run into someone in the hall or you're on a phone call, and in passing someone mentions a feature. Hey, that form field story coming up, that won't be too long, right? Maybe a 2 or 3, it won't go longer than a day, right? It'd be great to have that by Thursday to show to accounting. And the problem is, to the best of our knowledge, that is going to be an easy story. And in that moment, your mind is dropping that part of, to the best of our knowledge. I mean, you know it's an easy story, right? It's just a new form field. And of course, it would be helpful to your project manager, your client, coworker, business analyst, what have you, if they knew that it was likely they could show it off on Thursday. So it's really easy in the spirit of collegiality and your own confidence to say, yep, that'll be a quick one. And all of a sudden, the story is officially a 2 or 3. So let's play a little charades now. I'm going to play the business role, and at the end, you can estimate the story that I am presenting. So. Somebody got it, shopping cart. All right, how many people want to estimate this story, guys? Clearly, I just gave you some great specs, right? Somebody in the audience? 50? Probably an accurate estimate. So charades is when you don't have enough information to reliably estimate. Now, your project manager probably isn't miming shopping cart to you, right? But what if I'd said, log in for a small Rails app? I've been on the wrong side of that debate, and that debate was one with the words, we'll just use devise. Now, if you've been on a project for a long time, it's really easy to think that everybody is on the same page. And the reason why everybody was fine with, we'll just use devise, is because we were thinking, hey, login for this app should be pretty similar to most apps. We just need to support some basic logging in, basic features that we're all familiar with. And the problem there is that previous discussions about the application and assumptions about typical user experiences can stand in for story details. And we often don't know that what we're delivering isn't what is wanted until the last minute, when it's almost ready to deploy. So if the acceptance criteria or the specifications or the comps aren't clear or don't exist, this story is not one that should be estimated right now. because no team can possibly accurately estimate what it doesn't know. Charades has a sibling, and that's Dummy Bridge, where to play a 4-person game with 3 people, the 4th person's hand is played open face. We do this when we move forward with estimating without the right people present. We essentially speak for that person. And the problem is, if someone needs to be there, they really need to be there, especially if they're the ones who will end up doing the work. Now, if your team is like mine, we're supposed to share responsibility for the entire application. Anybody can pull any story, roughly within the same domain. And that can lead to the assumption that anybody can estimate any part of the application. And the reality is that most teams do end up with areas where at least one person is far and away an expert. And if that person is not available, that story should not be estimated without them. Slot machines. Slot machines is where your team's estimates are not revealed simultaneously. So slot machines themselves could have been built to reveal all values at the same time. They really could have. It might have been even easier. Instead, slot machine builders chose to make each wheel stop one after the other. It builds suspense, and it makes people feel that if they got 2 in a row, well, maybe the 3rd one's going to go. I'm going to win big now. Unfortunately, this is a bad thing for teams doing estimation. And it's easy to think that we're comfortable enough disagreeing with each other, that we can take shortcuts, especially when they speed up the process. And whether that shortcut is explicitly asking senior people to give their opinions and estimates first, or not calling more vocal members not calling them on the fact that they're giving estimates before the discussion is actually over. It's easy to think that, given that we're a relatively open team, people will speak up. But even among very egalitarian teams, where everybody really does feel empowered to take on anybody else, if they feel justified that they have a point to make, I've seen this have effects. It's especially apparent when someone says, "So, what do we all think?" And half the people interpret this as a signal to reveal estimates, which they do. And the other half think that it was a signal for more discussion. And they look furtively around the room real quick, and then they quickly come up with estimates. It won't surprise you that most of the people who lagged have chosen as their estimate the average of the speedy estimators. Well, why? Well, sure, they've seen everybody else's estimates, but also, the people who tended to think that the leader's question was a prompt for more discussion are likely the ones who continue to have concerns or questions. And they can start to feel out of place when they see a lot of people confident in estimating without that extra information that they feel they need. So they discount their own views and look for clues from the colleagues they see as clearly more informed. Now, I know it can save time, and it doesn't feel as rigid. But playing slot machines when revealing estimates really does cause you to lose valuable perspectives. Blackjack, my favorite one. Estimation blackjack is where if you go above everyone's estimate, you're out. So I found this is a common experience when a manager chooses to involve themselves in a discussion. Or on the consulting side, on client projects when we work alongside employees of client companies. When you're playing estimation blackjack, it can feel like your high estimates single you out from the project manager and the client team. I mean, how could something that simple take that much work? They've taken a look at the code and that's there and just needs to be ported over from another language and all the business logic changed. It's not more than a 2-pointer, right? So how do we get into this situation? Well, I've seen a lot of differing incentives and consequences as an employee and as a consultant. For employees on staff, I rarely have had any consequences when I estimate too low. I haven't been fired. I often haven't even had a single one-on-one talking to. When your estimate is too low, the group gets together, somebody takes some heat, and by and large, the team as a whole takes a lot of heat. But you're not yelled at, and at the end of the discussion, you shrug, your boss shrugs, and you say, that's the nature of software. On the other hand, if you estimate too high as a client employee, you risk not as a client employee, as an employee on staff, you risk not getting the chance to do the work at all. It's going to take how much time to improve that code? Oh no, company does not have time to afford that. You can make do with what you have. Are you telling me that what you've written is not quality work? And so as an employee, I'll estimate high if I feel like it, but I'll walk that back the minute I see any resistance if I believe strongly that this is work that should be done. As a consultant, however, the incentives and consequences are reversed. As a developer at a consulting company, I usually saw chunks of work that had already been contracted for. So the company, our clients, had already decided to fix that code or to improve it. They'd already negotiated a contract with us, or we were estimating to make sure that the contract was a good fit. Now, likely I've been very lucky, but I never really saw any benefit in the long term to estimating far too short. Because the disincentive to estimating short is to have the story turn out to be bigger than we estimated. The client feels cheated, and they feel like they're getting less for the hours they bought, and they feel like we've missed some deadline. And they don't have the experience working with us to trust that we are working as hard and as efficiently as possible. So where you and your boss might be able to shrug and have a common, software kind of moment, you don't have that common rapport with a client, and so the discussion gets very hairy very quickly. And so we get estimation blackjack, where if I estimate too high as a staff member, we risk not getting the go-ahead to do the work. And if we estimate too high as a consultant, the client is confused because their people are telling them it's easy because they're motivated to. And as a staff member, you end up with unrealistic estimates. And as a consultant, you end up losing the client's trust. Resistance. So resistance is a newer game compared to the ones I've discussed before. Resistance is a game of deception and spies, where a group of people are trying to launch a resistance against an evil military occupation. So the spies are trying to undermine the resistance. If you've played Mafia, it's somewhat similar. But for our purposes, it's a game of talking and convincing your teammates to agree with you. Sounds like an estimation meeting, no? Well, some friends loved this game, and they wanted to find a way of getting better at it. So, scientific people that they were, they had one person sit out for the game and watch the game proceed. Freed from any allegiance to one side or the other, this person was able to observe the game and find people's tells and see how people interacted. And they were able to get a lot of people to improve their communication. Some might say lying. We'll say communication. And everyone's tells and giveaways were identified and corrected. All the time. Put to the neutral, what is happening? Get communicating. Guys, the answer was minutes. The concept being dominated in just one. So why? Well, each spot is simple and in this room. I'm not a. The resistance simply because it was naturally more opinion. People who have a clear idea, even some people as I am, easier to speak for their point. It is to feeling of It's not a different area. To your just don't. It is all about to say, but user all the word you have to say environment. In that situation, what are you supposed to exactly, or the 5 things that will be so the problem becomes conversation and so I've back and felt you. Another reason for be clear to make detailed, precise, and accurate estimates were crucial for our communications with clients. We talked about that fact a lot. And so when you were halfway through an all-day estimation meeting, yes, I said that right, all-day estimation meeting, you knew why it was important and why it was benefiting your company. At my current job, the company I work with needs accurate but not precise estimates. We have 2 sizes for stories, big and small. I need to be correct when I say it's big or small. But this office does not need us to sweat the details about whether it's a half pint, bottle, bomber, quarter keg, half keg, or keg-sized story. And when we get into those decisions or those discussions, we know that we're off track, we know that we're wasting time, and we get back to programming. Respect uncertainty. This is a big one, and we saw this in resistance. It's really, really hard to be certain about uncertainty. Now, the friends who played resistance fixed this one way. Each round of talking was limited to 2 minutes. This limited the time that the confident people, the spies, had to dominate the conversation after some people expressed doubts. And I think that works for what is ultimately an arbitrarily structured game. But time restrictions can feel arbitrary in a workplace. So unless this is a big problem for your team, I'd suggest 2 rules. The first is consider someone being unsure as a fact, on the same order as the other facts that people present. Facts like, I've seen this class before, we won't have to touch that part of the application, etc. And secondly, always take the high estimate if there's a lack of agreement. Investing in concrete discussions has always been valuable in estimates that I've been part of. Your estimates will improve substantially in accuracy if you take the time to make sure your estimation discussions are as concrete as possible. Don't be afraid to block stories for clarification. And try spiking on it. Especially in more casual environments, estimating a story might actually involve writing some code so that the technical requirements are clear. Having clear business requirements, knowing what error message needs to go on the page at what times, doesn't tell you much about how those error messages are implemented in the code and what files will need to be changed. Small changes can appear a lot bigger when you start looking at the code. Big changes can start looking smaller. A corollary to that is that spiking on bugs is especially important. If estimating bugs is important to your company, and in some situations it's not, but if it is, make sure you know what the bug is before estimating. We had a fun bug come up a couple weeks ago where the users were not able to register with email addresses that had 2 dots in them. So if you're talking about like James at bbc.co.uk, or Ishimoto at nhk.co.jp. Well, yes, the story included the .co.uk example, but the bigger problem with the was with the .co.jp things. Shockingly, when we looked at our regex, it wasn't a problem with the periods. It was a problem with the fact that our colleagues in Japan were using 2-byte characters in their editors, which they should be, and then we're copying and pasting 2-byte characters for Roman numeral characters. And our regex has no idea how to validate something with nulls in every other byte. Spiking on that story allowed us to accurately estimate that as an almost zero pointer, instead of looking at that and wondering what the heck could be wrong with our regex. Finally, sometimes we just need a breather from our current communication patterns, and changing up our process can help us improve. Trying some more structured conversations, even trying out planning poker. I actually have never played planning poker. I think it would be interesting, and I think that it can help bring out different dynamics in a team if they need to reset how they're communicating. It's also important that you say when you feel overly influenced as a way of just bringing up these issues. If your team's dynamics for estimating are off base, sometimes just talking about how your process is being influenced can help change that process. And finally, if it helps, maybe using some of these games, saying, hey, I feel like we're playing estimation blackjack right now, can be easier than actually having a hard discussion about what exactly is going on. So thank you. I hope this was useful, and I would love to continue the discussion. On Twitter, I'm CD Wart, and I'd love to hear from you. Thank you.
Thank you very much, Amy, for coming. So I have some quick announcements, and then we're going to take a break before we hear from our next speaker. If you will bear with me while I load said announcements. I know the first one is that we have an Appy Hour sponsored by Apptentive. Get it? Ha ha! Yeah, it's hilarious. The Zeal guys liked it. Come on. So it's up the street here, and we're going to be hosting it at the Astro Lounge. It is a private party. They've got the whole thing. So if you don't have your badge, you are not allowed to come in, unless you're maybe like piggybacking on someone else or hiding under their jacket, stacked like in the cartoons. So the live stream for the event, someone asked me earlier, and I gave them So it is an absolute pleasure to introduce Akira. こちらは松田明です。彼は日本から来ましたので、浅草日のオーガナイズですね。So we're not going to actually introduce him in Japanese. I think it would be funny to just keep going like that, but you won't know anything about him. He's fascinating, actually. He he's one of the founding organizers, I think, of Ruby Kaigi and Asakusa RB. And Ruby Kaigi is the largest Ruby conference in the world. I think they had 800 attendees last year. And it was an amazing conference. If you ever get the chance, you should definitely go. Asakusa RB is also hosted near Ueno, there in Tokyo, every month. So if you get out there, you should stop in and say hello. Every week. Is it a weekly event? Oh my gosh. Every week. They're a little hardcore about their meetups in Japan. They take that seriously. So other things, like if you've ever had pages in a Rails app, paged events, that's probably Kaminari, that thing that he wrote. He also came up with the active args and action decorator gems, many gems. He's a core committer on Ruby and a core committer on Rails. Akira's fantastic. You should get to know him. He speaks English very well. He learned when he was on exchange in Zimbabwe, so he speaks with a little bit of an accent that you may not recognize, which is awesome. One of my favorite humans. Did you have a comment, Ryan? You have a lot to thank Akira for, so please walk up to him and say hello. It would be nice of you to tell him how much you appreciate all of his hard work. So, without further ado, I'm going to let Akira talk to you. I'm not going to. I'm going to keep going. I'm going to just keep talking because I like to talk. Like I am one of my favorite people to listen to. So, the happy hour that is happening tonight, again, is on what street? What is the street? Is it Bond? I lived in Bend for 2 years. I feel like I should know that. You don't even live here. Was that you, Eric? No. Oh, okay. It was someone over here who I assumed was Eric. Eric just knows everything. So we're going to have a happy hour tonight, and we thank AppTenant very much for focusing. I want to re-thank Zeal, our sponsor. I haven't seen any high fives for me. I feel like I should be getting a lot of high fives on Twitter using their high five app. What is the URL of the high five app again? StellarHighFive.com. Give some high fives to people on Twitter. And I'm still waiting for a heads up here. I think what we're happening is we're changing out video right now. So does anyone have any questions or comments or concerns about Ruby on Rails? No? Anybody want to take a break and high five their neighbor real quick? Everyone high five your neighbor. What's that? What is the beer count? Do we have a beer count? Who's winning the beers? Does anyone know? You're winning the beers? How many beers have you had? I feel like if someone asks you how many beers you have, you don't get to count your kombuchas. That's basically just rotten tea, bro. It's like tea with a giant mushroom on top of it. What do they call that thing? The mother? SCOBY, that's the word I'm looking for. I was talking to somebody who makes their own kombucha at home. He's like, every week I'm throwing away pounds of SCOBY. Like you make up these beef jerky? Is that what you call it? You can make SCOBY jerky? That is repulsive. Wow. That is, I mean, I was teasing about the fact that SCOBY is a nice word for just giant fungus, like pounds. It's like this thick. You're like, that is 8 pounds of fungus. But now you can make jerky, apparently. I would be down to try some SCOBY jerky. Red 15, blue 18. I'm sorry, blue's crushing you. Yeah, you got to step up your game. I think green team wins overall because I've had like 18 kombuchas, so I win the beer count. Are we good for video? We are good to go. Okay, once again, this is Akira Matsuda-san. If you want to say it in English, it's Akira Matsuda. Okay? All right.
Can I start? Okay. So let me start. So cheers, everyone. I'm from Japan to talk at this conference today. Japan is, of course, the country where Ruby was made. Thank you. So we have Ruby in Japan, and we have good sushi in Japan, of course. And also, we have great sake in Japan. So, actually, I brought a big bottle of sake, which is really high quality, amazing sake. For you beer drinkers, so, has a and head I'm very thank you. The language thing in Tokyo. I will company and it will to begin with is like 100,000, which is actively in main, like we make and use recipes from the menu by the ingredients. Sensor is like uses and philosophy must really always the solution just scale. Dinner time. Don't always right. So our increase and automatic shows the server. You see shape we're using Rust. There's called 300 finishes. Cap is run a so ours is than I don't know details. The author himself. 15 years. He topic is show something and no, we switch please consult the README if you want to know more. Anyway, the author looks like this, I guess. He's also a young guy. He's a freshman. And he made this plugin in one day. So he's yet another young super hacker in Cookpad. So the next topic is testing. We have 20,000 RSpec examples, and we heavily use Capybara integration testing. So running these tests takes 5 hours on my machine. But, we don't want to wait 5 hours until the test finished. Actually, 10 minutes is our goal to finish the test. So, how do we do this? The only way is to shrink the application size? No. We made our own version of parallel RSpec executor. Initially, this was like SCPing the source code to the remote machine, which was named remote spec. This solution was initially made by this guy, Oidoksa. Right. And we open sourced this with another name. And we currently use this software for both CI, on CI server and on our local machine for rake spec alternative. So the strategy is like this. It's distributed, remote execution, optimizes the test execution order, and it's highly fault tolerant. I'm going to explain about this later. And we use this kind of server, EC2 C3 8x large, it's a monster, which has 32 CPUs and 60 gigabyte memory. And on these servers, our 5 hours RSpec finishes in 10 minutes. Would you imagine this cost much? Actually, in fact, this is cheaper than any existing cloud CI solution. because we use spot instance, which means it's not always up, it's not always running. We use the server just when we're in need, running the RSpec. So it's very cheap. And here's another problem with testing. We used to use database cleaner, but because we have 1,000 models, it tries to delete from 1,000 models for each these 20,000 example, which is extremely slow. So we made our version of database cleaner. In fact, we do not use all these 1,000 models per each test. So why do we need to delete from all these tables? So this is our solution. We monkey patch active record, and we remember the names of the tables when inserting into the table, and delete from only those tables, which is sometimes like more than 100 times faster than database cleaner. This strategy was created by, again, Oidoksa, and I made it into a gem, so you can use this. And the next topic is migration. We do not use active record migration because we have so much databases and schema changes. So instead, we made our own version, which you can find on GitHub here. This is something like active record migration version of Chef or Puppet. And so next topic is how do we doing the prototyping on Rails? Like, we have 50 developers editing one single application. How do we avoid conflict on the application? We made our own prototyping framework on top of Rails, which is called Chanko. This helps rapid prototyping on Rails, again, created by Oidoksa. So this is very difficult to explain, but basically this framework contains with this framework, we can create something called a unit. The unit contains the whole model view and controllers inside the unit. And the unit can be enabled or disabled with just a flag. And yeah. And if any error occurs inside the unit, it doesn't throw the error to the parent application. It basically ignores the error and instead runs the original code on the parent application. So it's like A/B testing framework, kind of. The directory structure is very simple. We contain everything into one directory for each unit. So yeah, this is how we do. And the next topic is how we avoid being legacy. The application is like 7, 8 years old. It's been around since version 1.1, I think. And we keep upgrading to the, so migrate the application. You know, application. Rest and it also with and also we do right body each we just haven't anonymous. If you this or project. And yes, to and this is my today. It which in